Coriolis force deflects wind to the right of their original path in the northern hemisphere and to the left in the southern hemisphere. When eruption takes place, from the crater rushes out enormous quantities of superheated water vapor and other gases, carrying with them vast quantities of rocks, stones, ashes, lava and other materials. The ground shakes violently and there is a tremendous roaring sound. The column of gases and solid particles emitting from the volcano during eruption goes up vertically to a great height. The friction of the particles emitting from the vent creates static electricity. Forked lightning flashes to and fro and peals of thunder are heard. The rising column may be lit up by the glowing lava in the crater, so that the crater seems to be aflame. In some cases, the column that rises from the crater is so dense that it hides the sun and creates impenetrable darkness. The condensation of the steam as it rises aloft brings about torrential rain. The downpour is also partly due to the condensation of moisture-laden air drawn upward to high altitudes by the updraft created as volcanic gases are discharged. As the rain falls in torrents, Muddy River flows down the slopes of the volcano. The 0-degree meridian is known as the prime meridian. The other half of this great circle forms. Earth movements generate tensional forces that tend to pull the crust apart and faults are developed. If the block enclosed by the faults remains as it is or rises and the land on either side subsides, the upstanding block becomes the host. Tension may also cause the central portion to be let down between two adjacent faults, forming a graben. The breakup of Pangaea into 7 continents occurred at different stages. Around 180 million years ago, there were only 2 supercontinental masses, the Gondwana and Laurasia, separated by the Tethys Sea. Around 120 million years ago, Africa broke away from the South American continent. 60 million years ago, Northeast Africa broke apart to join Asia. Changes have continued till at present. The Earth is as we know it. If the plate keeps moving at the same rate, this is how the Earth will look 50 million years from now. Indian Standard Time Meridian, IST, is a meridian of 82.5 degrees east near Allahabad in Uttar Pradesh. As the Earth revolves around the Sun at a fixed angle with the plane of the ecliptic, the axis of Earth points to the same place amongst the stars, which is at an angle of 23.5 degrees. On June 21st, the sun rays fall perpendicularly on the Tropic of Cancer. This day is considered to be the longest day in the northern hemisphere and is known as the summer solstice. On December 22nd, the sun rays fall perpendicularly on the Tropic of Capricorn. On this day, the southern hemisphere has its longest day, while the northern hemisphere has its shortest day. This is known as the winter solstice. The circle of illumination, or the shadow circle, is the imaginary line that separates the lighted half of the Earth from the dark. Convectional rain is common in the tropics. When the Earth's surface is heated by conduction, warm, moist air expands and rises. In rising, it loses its heat, and the water vapor condenses, resulting in heavy. The distance between the equator and the poles are divided into 90 parallels of latitude at an interval of 1 degree. The Vosges Mountains in France were formed by doming of the surface combined with massive movements along fault lines that produced horst and grabens. In its journey around the Sun, the axis of the Earth is always parallel to its former position. The equator is an imaginary circle on the Earth's surface, drawn around the point that is of equal distance from the two ends of the axis. All lines of latitude are drawn at an angle from this point and are parallel to the equator. Here, the angle of 66.5 degrees is connected to the Earth's surface. From this point, a parallel is drawn to the equator. This is known as the 66.5 degree latitude. When rising moist air is confronted by a mountain barrier, it is forced to ascend. In ascending, it cools by expansion in the higher altitude till it reaches saturation point. Then it condenses in the form of cloud and eventually it rains. The rotation of the Earth causes the Earth to bulge at the equator so that it looks like an orange. The Earth rotates around its axis from west to east, facing the Sun through 360 degrees in a full day. If you take a ball and spin it fast on your fingertip, the point of the ball touching your finger will be the South Pole. And now try to imagine extending the finger right through the ball to the other side. This would be the axis ending at the North Pole. As we move east from the meridian of 0 degrees, we gain time and experience earlier sunrise. For every 15 degrees east, we gain an hour. By the same reason, as we move west from 0 degrees, we lose time at the same rate. This principle is applicable not only to the 0 degree meridian, but to all meridians. A complete network of meridians of longitude and parallels of latitude crisscross on the globe in order to determine the location of any point on the surface. This is called the Earth. The important parallel of latitudes are the equator at 0 degrees, the Tropic of Cancer at 23.5 degrees north, the Tropic of Capricorn at 23.5 degrees south, the Arctic Circle at 66.5 degrees north, the Antarctic at 66.5 degrees south, and the North and South Poles. The deflection of free moving masses due to the rotation of the Earth is known as the Coriolis force. In reality, the moving object does not change its path, but the Earth's rotation, with us on it, creates this illusion. At the equinoxes, the shadow circle passes through both the poles and cuts all parallel in halves. This results in equal day and night all over the world. The rotation of the Earth from west to east brings about the eastern hemisphere into the sunlight before the west, and thus creates the illusion that the sun rises in the east. Cyclonic rain is due to the convergence of two different air masses of different temperature. Cold, dense air tends to remain close to the ground, while the warm air rises above the cold air, and in the consequence, it expands and cools. condensation takes place and light showers occur. As the Earth revolves around the Sun, each place on the Earth's surface experiences difference in sunlight, from maximum to minimum. The position marked in red in the northern hemisphere at autumnal equinox is in half sunlight. As winter approaches, it moves further away from the vertical rays of the Sun. With the coming of spring, it emerges again into sunlight till at the June solstice it appears to be in the full rays of the Sun. Fold mountains are formed by folding of rock strata by lateral compression induced by endogenetic forces. The axis is at an angle of 66.5 degrees to the orbital plane and 23.5 degrees to its perpendicular. The path of the Earth around the Sun is elliptical, and within it, the Sun is not placed centrally. This causes the distance between the Earth and Sun to vary at different times. Around the 3rd of January, at the perihelion, the Sun is closest to the Earth. During the 4th of July, at aphelion, it is at its furthest. Revolution is the counterclockwise movement of the Earth around the Sun in about 365 days, 5 hours and 48 minutes. Though the Sun holds a fixed position in the solar system, the path of the Sun in the sky appears to be changing northward and southward. In reality, it is the Earth that changes its position in relation to the Sun. From its position in the March equinox, it moves to its position in the June solstice, from where it is again back to its equinox position in September, and again to a new position during the December solstice, from where it returns to its first position of the March equinox. Each meridian cuts the equator at a right angle. The 180-degree meridian is universally recognized as the international dateline. Officially, this is where each new day begins. To avoid political inconvenience, the dateline has been made irregular.